Hello students and welcome back to the next module of our problem solving on shortest distance between lines. Okay, let us start. The first question says find shortest distance between the lines, and these are the given lines. Alright students, if you look at them very carefully, these are vector equations of lines, right? And we need shortest distance. So let us start. In solution, we take the first line, r bar is equal to 4 I cap minus j cap plus lambda times I cap plus 2 j cap minus 3 k cap. Now if we compare this line with standard form, r bar is a1 bar plus lambda times b1 bar, we get a1 bar as 4 I cap minus j cap and b1 bar as I cap plus 2 j cap minus 3 k cap. Okay students, similarly we take the second line, r bar is equal to I cap minus j cap plus 2 k cap plus mu times I cap plus 4 j cap minus 3 k cap. And when we compare this again with the general form, we get a2 bar as I cap minus j cap plus 2 k cap and b2 bar is second part, that is I cap plus 4 j cap minus 5 k cap. Alright students, now once we get these values, now we know the shortest distance has an expression. It is mod of box product of a2 bar minus a1 bar, b1 bar, b2 bar divided by mod of b1 bar cross b2 bar. Right? Now let us calculate numerator separately. The numerator says a2 bar minus a1 bar, b1 bar, b2 bar. This in for the problem becomes determinant minus 3, 0, 2, 1, 2, minus 3 and 1, 4, minus 5. On simplifying this students, we get minus 3 into minus 10 plus 12 plus 0 plus 2 into 4 minus 2, and this becomes minus 6 plus 4, that is minus 2. So now we got the numerator part. The denominator part is b1 bar cross b2 bar. It becomes determinant I cap j cap k cap 1 2 minus 3 and 1 4 minus 5. On simplification, it is 2 I cap plus 2 j cap plus 2 k cap. Remember students, we require magnitude of this. So the magnitude becomes b1 bar cross b2 bar is square root of 4 plus 4 plus 4, that is square root of 12. Now once we have numerator and denominator ready, let us proceed for the shortest distance. Shortest distance becomes mod of minus 2 upon square root of 12. That is nothing but 2 upon 2 root 3. When we cancel out 2, we get shortest distance as 1 upon square root of 3 units. Alright students, so here we saw how to find the shortest distance from vector equations, right? Question number 2 says, by computing shortest distance between the given lines, determine whether the following lines are intersecting or not. Let us proceed. From the Cartesian equation 1, that is x plus 1 upon 7 equal to y plus 1 upon minus 6 equal to z plus 1 upon 1, we can get by comparing with standard form x minus x1 upon a1, y minus y1 upon b1 and z minus z1 upon c1. We get x1 as minus 1, y1 as minus 1, z1 as minus 1. a1 is 7, b1 is minus 6 and c1 is 1. Okay students, similarly we get the similar data from second line. The second line is x minus 3 upon 1 equal to y minus 5 upon minus 2 equal to z minus 7 upon 1. When we compare the same with the standard form again, we get x2 as 3, y2 as 5 and z2 as 7. a2 is 1, b2 is minus 2 and c2 is 1. Now students, once we extract all this data, now we can find out the shortest distance, that is magnitude of determinant x2 minus x1, y2 minus y1, z2 minus z1. By now we should by heart this a1, b1, c1 and a2, b2, c2. The denominator part is square root of b1 c2 minus b2 c1 the whole square plus a2 c1 minus a1 c2 the whole square plus a1 b2 minus a2 b1 the whole square. Now when we put values in this expression, we get the shortest distance. So let us get it. These are the values and shortest distance becomes determinant of 4, 6, 8, 7 minus 6 1 and 1 minus 2 1. The denominator becomes square root of minus 6 plus 2 the whole square, 1 minus 7 the whole square plus minus 14 plus 6 the whole square. On simplification, we get the shortest distance as 4 into minus 6 plus 2 minus 6 into 7 minus 1, 8 into minus 14 plus 6 divided by 16 plus 36 plus 64 under root. And this gives shortest distance as minus 16 minus 35 minus 64 upon root of 116. This becomes minus 116 upon root of 116 and it is square root of 116. Now students, that is 2 root of 29 units. Now once we have shortest distance, we can conclude that as the shortest distance between the lines is not 0, the lines do not intersect. Alright, this completes the module. Thank you.